Hello my dears, how are you all? So in the last class we discussed about the what? The concept of the poles and zero concept. We discussed it, how can we find the time constant of a certain system, and transfer function, what is the meaning of transfer function, that we discussed it. So today we are going to discuss very important session, first order system. First order system. So first order system means, what is the order, what do you mean by order of the system, ideas? What do you mean by order of the system? You heard from the very basics, right? From the first year itself you heard the word order, right? So what do you mean by the order? What is the physical significance of the term order? Dears, the term order means it is the number of reactive element in a system. Suppose it's a first order system, means there is only one reactive element here, that is nothing but our capacitor. If the second order system means, there will be two reactive elements. So the number of reactive elements simply refers to the order of the system. So this is the first order system, which means simple reactive component, single reactive component. This is RC and this is an RC network. So this is an example of a first order system. So this is a time domain representation, and remember one thing, for transfer function and analysis of a system is very easily carried out by what? The Laplace transform. Very easily carried out by Laplace transform. So please convert any time domain quantity into S domain, because it is very easy to analyze the stability of the system. If you know the things in S domain, it's very easy to find transfer function, right? It's very easy to find transfer function. If you know the transfer function, many things can be learned. So important is that we have to convert always our time domain system to S domain system or Laplace transform, because it's very easy. So what will be from Laplace transform, from Laplace equivalent circuit, what will be, my dears, V of S? V of S I can write like VA of S into 1 by CS, correct? Divided by R plus 1 by CS. Am I right or wrong? Am I right or wrong, my dears? Because when you multiply the capacitor with 1 by CS, it will be in ohm, and if you multiply inductor with S, it also will be in ohm. It also will be in ohm. So 1 by CS is in ohm and LS is also in ohm equivalent. So this is an ohm equivalent quantity. So this one is this one ohm and this another ohm. So voltage division rule simply apply there. So voltage division rule, according to voltage division rule, V0 of S equal to VA of S into 1 by CS divided by R plus 1 by CS. So I am taking 1 by 0 CS as outside. So it is simply 1 by CS whole divided by, from denominator I am taking 1 by CS as output. So it will be RCS plus 1. 1 by CS would cancel. So it will become V0 of S become VA of S divided by 1 plus RCS. Simply, my dear, VA of it divided by 1 plus tau S, where tau is equal to what? RC is equal to time constant of a system. Time constant of the given system. Time constant of the given system. That means to this system it is a time constant. So this can be right like V0 of S divided by VA of S equal to 1 by tau S, right? 1 by tau S. Am I correct? Or V0 of S divided by V of S is nothing but, my dear, transfer function. Laplace transform output by Laplace transform input is nothing but transfer function. 1 divided by 1 plus s2. 1 divided by 1 plus s2. This is the transfer function of the first order system idea. This is the transfer function of a first order system. Okay, then what will be, so now you have the value of what, transfer function. This is called the closed loop transfer function. Closed loop transfer function of a first order system. Now we are going to check what will be the nature of the output, or what will be the transfer function, or simply what will be the nature of the output when we give step input, when we give impulse, when we give ramp input, etc. Right? Okay, let's learn that. Because in the syllabus it is clearly mentioned that unit step input, ramp input, yeah, impulse response of like first order system is clearly referenced. Clearly refer that. So definitely a question will be asked from this session. Okay. So 1 divided by 1 plus s2 is, please remember this, this is the transfer function of a first order system idea. First order system. Second order system it is different. So that's why I told you to remember this. Okay. Okay, so let's see what is the impulse response. That is impulse response, which means what happens when I am giving an input signal as impulse to the first order system, what will be its output. That is we have to find. That is we have to find out. Okay, which means clear. Listen. So my recording is okay. Yeah, it's okay. Let me check that. Yes. Listen, my dear. So impulse response. So which means if x of t will be equal to del of t, then what will be the y of t will be what? That is the aim of our analysis. If the same first order system, if we are giving the impulse as the input del of t, why we have to give this type of input as what the why we have to give this type of inputs? Because in the real system or the practical system ideas, there are so many cases where similar to these type of inputs may be accidentally happened on the system. So we have to predict the response of the system already, so that we can take necessary precautions or necessary measurements for particular that happening. It may be adversely affect our system, or it may be it may be very good for the system. So it depends upon the nature of the sudden response or sudden input that we. For example, lightning is like an impulse. Lightning is like an impulse which exists for very short duration of time, with very huge magnitude. So if you already learn the system, what happens if I give an input? What happens if I give an input means you can predict, okay, what happened when lightning comes. The same response will be there also. So you can take necessary if there is any precaution for protection of the circuit, etc., etc., okay, for the noise reduction, etc. So anyway, we have to predetermine what happens in the system if you are giving some test signal. This is called the test signal ideas. So if x of t is equal to del of t, then what will be y of t? So what is x of s then? If x of t is equal to del of t, what is the Laplace transform of the del of t is nothing but simply 1. So we have y of s by x of s equal to what, my dear? 1 divided by 1 plus s2. Am I correct? So y of s will be equal to x of s divided by 1 plus s2. So x of s is nothing but 1. So 1 divided by 1 plus s2. Am I correct? So y of s will be equal to, my dear, 1 divided by, I am taking s common, so 1 by s plus 2. 1 by s plus 2. 1 by s plus 2. Yes, 1 by st. No. I'm taking tau as output, my dear. Tau, not 1 by s it is. So it will become 1 by tau plus s. Yeah. Yes. So I'm taking tau output so as common. So 1 by tau into 1 plus s tau. Correct, na? So this is y of s, my dear. Then what will be y of t? Taking the inverse Laplace transform. So it is in the form of y of t. 1 by tau is a constant. I took it outside. 1 divided by s plus a. What is the inverse Laplace transform, my dear? It is minus e raised to minus st, right? So e raised to minus t by tau. Correct? E raised to 8. 1 divided, what is the Laplace inverse Laplace? That is L inverse of 1 divided by s plus a will be equal to e raised to minus 80 parts. That's all. L inverse of 1 by s plus a is nothing but what here? E raised to minus 80. So it will become e raised to minus a is minus 1 by t. Na? So minus 1 by t into t. So e raised to minus t by tau. Correct? So into u of t. Why I am always taking this u of t as multiply means it's a unit step of function, my dear. If I represent this is standard representation. Even if it is not u of t, it is simply mean that what? If I multiply u of t means this is the meaning that this system is exist for t greater than 0 condition. This system is exist for t greater than 0 condition, not the history. That is the meaning why I multiply this always u of t. If it is not u of t means we can't get an idea this response is as a history or this response is exists for a very long time, we don't know. So after t equal to 0, how can we represent a response means multiply it with the input, that is u of t. Multiply it with not with the input, multiply it with the u of t. So simply not doing u of t means it will make confusion. So u of t means it's clearly it will be greater than 0. So this is the response of the system if the input is an impulse signal. This is very important, man. This may be asked. 1 by tau e raised to minus t by tau into u of t may be asked. Okay, and check whether the system is stable. That means if you are passing an impulse response, if you are passing an impulse to the system, so we have to determine this is the response. Is the system is stable still? We have to check that. For that, check for absolutely integrable. Absolute integrability. Absolute integrability, which means, listen my dear, that is absolute integrable means y of t at t tends to infinity you have to find out. Find y of t at t equal to infinity. So this is y of t. When put t is equal to infinity means it will become e raised to minus infinity. So it will become 0. If it is 0 means it is stable. It is stable. Or right, if it is 0 means it is absolutely integrable or stable. Both you can write. Both you can write. It is absolutely integrable or stable, my dears. Or stable. Is it clear, my dears? Is it clear? So this is the impulse response. So next step response. Next we have to see step response. Step response, which means x of t will become what, my dear? If it is a step means it will become what? U of t. Unit step means it will become unit step. So unit step response you can write. Unit step response you can write. Unit step response. Simply step response means it will be a into u of t. So unit step response is very easy, right? So unit step response. So what will be x of s, my dears? For u of t it will be, for u of t now the Laplace transform is 1 by s, correct? So what is y of s now? X of s divided by 1 plus s2, correct? X of s divided by 1 plus s2, which is nothing but x of s divided by tau into 1 by tau plus s, correct na? Correct na? So what is x of s now? It will be s now. So it will be 1 by s into tau into 1 by tau plus s. 1 by tau plus s, correct? So tau is a constant, so we can take it outside, no issues there. So 1 by tau you can take it outside. Simply it will become 1 by s into 1 by tau plus s. 1 by tau plus s. So this is nothing but our y of s. So what will be y of t? L inverse of y of s, correct? L inverse of y of s. Then what will be, my dear? That is nothing but L inverse of 1 by tau into 1 divided by s into 1 by tau plus s. Correct? Correct, my dears? So 1 by tau is always constant, so it is simply 1 by tau into L inverse 1 by s into 1 by tau plus s. How can we solve for such a equation? For solving this we have to use partial fraction method, which means I am focusing on this now. Okay, my dear, 1 by tau let be there. So I am going to take the partial fraction of that, okay, which will become, my dear. So what I am going to do, 1 by s into 1 by tau plus s. I may take like a by s plus b divided by 1 by tau plus s. So for finding the value of a and b, there is a rule, very easy rule called cover-up rule. It's a rule called cover-up rule. So you can use that rule and you can find the value of a and b very easily. So what is a now? So for getting the value of a, my dears, so simply a, okay, a, for getting the value of a, so what you have to do means, what is the denominator here? For a, it is s. Suppose s, make the denominator equal to 0, make the denominator of a is equal to 0, which means s is equal to 0, right? So cover this equation of this s, cover this equation, this means portion of equation containing a, cover this. So 1 by s I covered, because a I have to find, so corresponding a into 1 by s term, 1 by s term, that I have to cover up. Substitute the remaining term in this expression, correct, in this expression as s is equal to 0, which means 1 by, this one is there now, so 1 by 1 by tau plus s is equal to what? 0. So it will become tau. So the value of a is nothing but tau. Then what? How can we find the value of b, my dear? For finding the value of b, denominator of b makes it is 0. 1 by tau plus s is equal to 0, and s is equal to minus 1 by tau. S is equal to what? Minus 1 by tau. Substitute this s value by cover up the b term in the original equation. So listen, this is the b term, 1 by tau plus s na, this is the b term. So cover up that b term, cover up that b term. What will be the remaining term? Only 1 by s. Substitute s is equal to minus 1 by tau there. So it will become 1 by, substitute s is equal to minus 1 by tau, simply minus tau. Simply what, my dears? Minus tau. Is it clear? So you got the value of A and B. So now substitute in the equation. So it will become what? So 1 divided by S into S plus 1 by tau will become A by S, that is tau by S plus minus tau divided by 1 by tau plus S. Correct? Correct, my dears? So what will be the L inverse? What will be y of t now, my dears? What will be y of t now? Y of t is equal to 1 by tau is there as outside. So tau by S, L inverse, I will write like L inverse tau by S minus tau divided by S plus 1 by tau. So it will become tau and tau that can cancel constant. What is 1 by S means? Is simply u of t minus 1 by S plus tau, S plus 1 by tau. This tau and this tau again cancel out now. So 1 divided by S plus A, what is that? E raised to minus AT. So minus 1 by tau into tau, u of tau. So generally u of tau into 1 minus e raised to minus 1 by tau into t. So this is nothing but our y of t. U of tau into 1 minus e raised to minus 1 by tau into t. This is nothing but our response, my dear. This is nothing but our response. Very, very important. They may not ask you the derivation and all, but for your understanding purpose, I derive for first order system at least. So this equation you have to remember all the time. Y of t is equal to u of t into 1 minus e raised to minus t by tau u of t. That's it. Okay, so that's all about the unit step response. Unit step response. Unit step response. Next. So if I apply unit step response, there will be a chance of error. Because this unit step now, it is existed for very long duration. So there is always some error, my dears. There is always some error. So the error of the system. Error. So error is equal to the steady state error, my dear. Steady state error will be equal to, or simply the error E of t. E of t will be equal to input minus output. Input minus output. Sir, what are you saying? In terms of error is equal to input minus output. Yes, it is true. In control system, suppose our AC is 21 degrees Celsius now. So you increase it to 25 in your remote. So you give the input as 25 now. After some time, after some time, you have to check whether the AC is now working in 25 or the atmospheric temperature now is in 25. So the input you gave to the system is called simply the input of the system. That is the input to the remote. But the surrounding atmospheric temperature after some time is called the output of the system. So the difference in the input you applied and output of the system will be definitely the error, right? Correct? So this equation is satisfied? Okay. So in case of step response, the unit step signal, what is the input, my dear? It is simply u of t. Am I correct? Simple u of t. What is the output? U of t into 1 minus e raised to minus 1. So it will become u of t minus u of t plus e raised to minus 1 by tau into t. U of t can cancel. U of t is equal to e raised to minus 1 by tau into t. This is called the error. This is called the error. This is called the error. So always write u of t also. Always write u of t also. I already told you, simply you don't write anything in control system. always multiply with some u of t, because it represents the error is for after t greater than 0, that's all. Then the steady state error, my dear, there is a term steady state error, which is nothing but limit t tends to infinity u of t. The meaning of steady state error is that this is for the instantaneous error, my dear, but steady state error refers to after very long duration of operation, whether the system having still the error, that is called the steady state error. This is the instantaneous error because it is contained t terms. This is the instantaneous. At any time t, this is the error. But we have to check after some time, right? After 1 hour of operation or 2 hours of operation, whether the system still contain that error. We have to monitor now. We have to check now. So that is why the meaning the steady state error. That means after steady state attained, after some time, after very long duration. So the steady state error will be seen. Now in the case of here, if you apply limit to t tends to infinity now, what do you get? 0. So which is an indication that there is no steady state error. Which is an indication that there is no steady state error in the first order system if the input is what? Step input. If the input is step input. So clear, my dears? So clear? Okay. Next, time constant or time delay time. Delay time represented by TD. Delay time means it is the taken by the response to reach 50% of output. It is the time taken by the response to reaches 50% of its final value. The output value is simply final value. That is correct. Final value. That is called the time, delay time TD. For first order system, my dear, the TD is given by 0.693 into tau. 0.693 into tau. Where tau is equal to time constant. What is the meaning of time constant? Which is nothing but time taken by the response to attain 100% of the final. For example, consider the case of a capacitor charging. It is initially charged from 0 voltage and finally it reaches up to 10 volt. So the time taken for this is called the what? Time constant. You already know this, right? You already know this. So it will take a time, that is called the time constant of the system, which is nothing but tau equal to R into C in the case of a RC circuit. In the case of a RC circuit. So clear? So clear, my dear? So that is the delay time. Next one, rise time. Rise time. These all are definition, my dears. So rise time means it have very what? How can I say simply? Now just remember this. Second order system while taking it will be more and more clear. So rise time means it is the time taken by the response to reach from 10% to 90%. Okay, so that is called the rise time. So rise time TR will be equal to 2.2 into tau. 2.2 into tau is equal to RC, correct? For first order system, tau will be equal to RC. So rise time means nothing but, my dear, 10 to 90% in what time the response will attain. You will have a what not clarity now, I know that, because you don't have that imagination, right? What is actually happening there? While taking second order system now, these things will be more and more clear to you, definitely more and more clear to you. But there is a limitation to take second order response now, that is why. After some time only I will take, okay. So that is called the what? Rise time, my dear, rise time. Next, settling time. Next definition is settling time. Settling time. Settling time. That means it is a time taken by the response to attain the final value with a particular tolerance. That means settling time T is equal to 3 tau, 4 tau, 5 tau. For 5% tolerance, 2% tolerance, 1%. I will explain what is this after taking second order. It will be then only it will be more clear, my dears. So now see, there is a limitation for second or taking second order now. So just note it down. I will take second order system, then it will be more and more clear to you. Okay, just listen this TS. So TS will be 3 tau, 4 tau or 5 tau for 5%, 2% and 1% tolerance respectively. Okay. Next, what happens when in the first order system you applied impulse, you applied a step, okay? Then what happens if you apply a ramp? What happens if you apply a ramp? That is called the ramp response of the system. Ramp response of the system. Which ramp means nothing but, my dear, x of t is equal to what? T into u of t. Am I correct? X of t will be t into u of t. So x of s will be what? 1 by s square. Correct? X of s will be equal to what, my dear? 1 by x square. So what will be our y of s by x of s now? 1 divided by 1 plus s2, right? Or simply 1 divided by tau into s plus 1 by 2. Am I correct, my dears? So what will be y of s now? Simply 1 by s square into s plus 1 by 2. So 1 by tau is also there now, 1 by tau is there. So how can we find the y of t now? How can we find y of t now? So that we are using again the partial fraction technique, my dear. So I can write like 1 by tau constant now, you can take it outside. So 1 by s square into s plus 1 by tau will be equal to a by s plus b by s square plus c by s plus 1 by tau. This is the partial fraction rule, my dear. This is partial fraction rule. Suppose the denominator is s square, means you can directly like a by s square, but a by s plus b by s square plus 1 by means what? C by s plus 1 by tau only you can apply. Again you can apply the cover up rule now, but the denominator here now, it contains a factor of s square and factor of s plus 1 by tau. So the cover up rule only applicable for b and c only, because b containing s square as denominator, c containing s plus 1 by tau as a denominator. So only the cover up rule will apply for finding the coefficient b and c, finding the constant b and c, not for a. Okay, let's find b and c now, my dear. So I can write like, how can we find the value of b now? So v will be equal to this 1 by, cover up this s square now and put s square equal to 0 now. Put the denominator equal to 0 now, then what value of s that you have to put there. S square equal to 0, so the s will be definitely 0. Substitute s is equal to 0 there, so it will become 1 divided by 1 by tau, simply tau. And what is c now? C again you have to find by cover up this term, my dear. S plus 1 by tau you have to cover up, and substituting s is equal to minus 1 by tau in remaining equation. So it will become, my dears, s is equal to minus 1 by tau you have to substitute. So it will become 1 by minus 1 by tau, right? Minus 1 by the whole square, correct now? So it will be simply tau square. Simply tau square. So you got the value of b and you got the value of c. How can we find the value of a, my dears? So for that you simply cross multiply this. 1 by this much can be split up into this means, which is an indication that this equation can be equivalent to, my dear, this equation can be equivalent to what? 1 will be equal to, that is numerator will be equal to, cross multiply this, my dears. So it will become a by s into this much means a into s plus 1 by tau, correct now? A by s into the cross multiply every term, that's all, my dear. This is one term, you imagine like this is one term, and this is denominator and this is numerator. So 1 by a is equal to b means 1 is equal to ab. Na? So in that way you simply cross multiply this. So it will become what? A by s into s square plus s plus tau means a by s square into s, a by s into s square plus s plus 1 by tau means simply as into s plus 1 by tau plus b into s plus 1 by tau plus c into s square, correct now, my dear? C into s square equal to what, my dear? 1. So now you have 1 is equal to a s into s plus 1 by tau, right? A is into s plus 1 by tau. So okay, fine. See, compare the coefficients, my dear. Compare the coefficients. Take s square term. S square term is equal to nothing but a now plus b is not that c. So a plus c is equal to what? 0. C you already find, right? C is equal to what? Tau square. So a is equal to minus tau square, simple. C you already find a tau square. So a plus c is equal to 0 means a equal to minus tau square, that's all. So now you got all the values of the constants. So substitute these. So what I get, my dear? So my y of t will become, or simply y of s, you can write like y of s now. Y of s equal to what? A by s, which is nothing but 1 by tau is outside, my dear, that you don't forget. Okay, so our y of s will become finally a is nothing but minus tau square. So minus tau square divided by tau will become minus tau. minus tau by s, correct? A by s plus b by s square. B is what? Plus tau. And that plus tau and this outside tau will cancel outside. So it will become 1 by s square plus c. C is equal to what, my dear? Tau square. And tau square and this tau outside will cancel out, simply tau. Tau by s plus 1 by t. So this is that y of s. And how can we find y of t, my dear? Y of t will become tau into u of t, correct now? Plus t into u of t plus tau into e raised to minus 1 by t. 1 by tau t. Everything you have to write, every time you have to write q of t, because for t greater than 0, simply, my dear. Okay, just like this. So this is the response. This is the response. Minus tau into u of t plus t into u of t plus tau e raised to minus 1 by tau into t u of t. This is the response. Okay. Okay. Then what is the error now? What is the error now? Error e of t will be equal to what, my dear? Input to minus output. What is the input now? What input you applied now? You applied a ramp signal, correct? So it will be t into u of t you applied. So t into u of t minus, what is output now? Minus of this much. Minus of this much means it will become plus t into u of t minus t into u of t minus tau into e raised to minus 1 by tau into t. So this t into u of t and t into u of t could cancel simply by this. Tau into 1 minus e raised to minus 1 by tau t e of t. That is called e of t. That is called e of t. Okay. Then what is steady state error now? Steady state error is equal to limit t tends to infinity what? E of t. So it will become, apply t tends to infinity now, then this term will become 0 now. This term will not be there. So simply tau will be the result. So the error will be nothing but tau. The error will be nothing but tau, which is equal to RC. So this much error will be there when it is operated for a very long time, very long time. That is the physical meaning. That is the physical interpretation. What is the physical meaning? Is it clear? Is it clear, my dears? Okay. The partial fraction now, this is mathematics simply. So you have to take care of that mathematics. So there are so many tricks for the partial fraction. You can refer YouTube, right? YouTube is a very good platform for self-study. Okay. Okay. Now write a problem, my dear. If t of s will be equal to, the transfer function will be equal to 1 divided by 1 plus 2s. 1 divided by 1 plus 2s. Find TR, TD and TS for 2% tolerance. 2% tolerance. Okay. So if you know, if you have this question in your examination, just now you studied about first order system, but now you can see this is a first order system. How can we find? Compared it with the standard equation transfer function. That is why I told you, remember the transfer function. The transfer function of the first order system was what? 1 divided by 1 plus s tau, right? 1 divided by 1 plus s tau was the equation of the standard what? Transfer function of first order system. So compared it with standard equation, one divided by 1 plus s tau. So tau will be now equal to 2. Correct? No? Tau will be now equal to 2. So find TR. TR will be equal to 0.693 into tau. That's equal to 0.693. 0.693 into 2. You can calculate that, okay? And rise time and delay time. TD equal to 2.2 into tau. 2.2 into 4.2. And settling time for 2% tolerance, my dear. So for 2% tolerance, settling time, refer the previous session. What is that? 3 tau, 4 tau, 5 tau for 5 to 1% tolerance. So 2% is 4 tau. Correct, no? So it is nothing but 4 into tau is number 2. 8. So 8. Is it clear? Is it clear, my dears? Is it clear? Okay. This is a question you can expect, because it is, you have to think. The answer is only actually one step, but you have to think a little, right? Have to think about it. And only answer will be obtained. Okay, write another question, my dears. Figure shows the step response of a first order system. Determine the time constant. Determine the time constant. So this may be asked because it's that much. It is easy actually, but it is highly observable question. What is the meaning of this time, my dear? So what was the definition for settling time? The settling time was, it is a time taken by the response to reach its final value with some percentage of tolerance, correct? Here now 2% of tolerance is that. What is the physical meaning of that? Nothing but, my dear, if you apply some input, there will be some response. The response suddenly not attain that final value, like the indicating instrument you already mentioned. The pointer suddenly it will not come here. Slowly come here and finally it will oscillate for some time and finally it is settled. In the case of a control system, the expected output suppose is 2. You suppose the expected output is 2. The system will not attain 2 as long as, suppose you observe the system for infinite time, then also it will not attain exactly 2. It will nearly 1.99, 1.98, 1.999, etc. etc. There will be a rotation or there will be an oscillation around its final value. It's always happening. Only in ideal system, if you set for 2, then definitely it will 2. But for practical system, it will not be happening. So there will be some tolerance range. That means there will be some error range, my dear. That is called 2%. That means suppose the output is 1, you are expecting, but 2% error will be there means, what is the meaning? 2% loss will be there from 1. So that much, with that much loss the system is working. That is the meaning. So the time to up to this is called a settling time, idea, settling time, TS, which is given by 0.02. If settling time is given, then what will be the time constant? Time constant tau will be equal to what? How can we find it? Time constant tau. We have settling time TS is equal to what? 3 tau, 4 tau, 5 tau, 4, 5, 2, 1%. So it will be 4 tau for 2% tolerance. I already write now. I already write right. So it will become what? Tau will be equal to TS by 4. 0.02 divided by 4. That's all. So that will be the settling time. That will be the settling time. Correct? 0.02 by 4 means it will be 0.005. Correct? It's 2 by 100 into 4 now. 1 by 200 now. 0.05. Correct. Correct? Is it clear, my dears? Is it clear? 1 by 200 correct now? 0.05 correct? Because 1 by 2 is 0.5, 1 by 20 is 0.005. 1 by 2 is 0.5, 1 by 20 is 0.05, 1 by 200 will become 0.005. Okay? That's it. Is it clear? Any type of question may be asked by dears, and be prepared for very difficult questions. Then only, if you see the questions on the question paper, you will be very happy, because that all question will not be up to your level of answering. So you will be very happy then. Right, next question. What is tau? For first order system. Generally the first order system response will be like this way, because there is only one RC combination, right? One RC combination is there. So the charging of the capacitor and discharging of the capacitor you already learned, right? So in similar manner the response also will be. So this is the response of the first order system. So by looking itself you have to understand. Okay. So input is 5 into u of t. What is tau, my dear? Tau. You have to find the value of tau. That means, listen, the output is nothing but, my dear, 4.2 at a time 0.35, which is indication that y of t will be equal. What was the equation? 1 minus e raised to minus 1 by tau into t. This is the equation of the response of a first order system, correct? Response of a first order system, correct? Response of a first order system, correct? For step input, because it is already given x of t is equal to 5 into u of t means it is a type of step input but magnitude 5. That's the only difference. So So for that 5 into u of t will become 1 minus e raised to minus 1 by tau into t, 5 into u of t. Correct now? This y of t is given, my dear, it is 4.2. So I can write like 4.2 will be equal to 1 minus e raised to minus 1 by tau into, what is t now? T is nothing but 0.35. 5 into u of t. So it will become 4.2 by 5 equal to 1 minus e raised to minus 0.35 by tau u of t. So it's simply 4.2 by 5 minus 1 equal to, simply you can calculate of t because you already subtracted, right? Minus 0.35 tau. So it will become 4.2 minus 5 is minus 0.8 now. Correct? Okay. 0.8 by 0.5. 4.2 now, correct? 4.2. Okay. So what will be now? Taking log on both sides, my dear. ln on both sides. So ln 0.835. ln e raised to minus x is simply, so tau will be that is the answer. Yes, that is the answer. Is it clear? Is it clear, my dears? So this type of question you may expect. Any question may be expected, right? But you have the idea, that is the main thing. You have a basic knowledge of what is happening there. You have to feel it, you have to touch by it your mind, okay, and you can solve. Okay, that's all. Okay, my dear. Next is second order system. This Laplace equation equivalent to E0 of S. So second order means nothing but, my dear, there will be two reactive elements. One is C and one is L, that's all. That is the meaning of order, simple. So convert it into Laplace equivalent circuit. This will be the figure. So VA of S R LS and 1 by CS. And now what will be V0 of S, my dear? It's nothing but VA of S into. The whole will be like a series circuit now. So voltage division rule can apply there. 1 by CS whole divided by R plus LS plus 1 by CS. So it will become, my dear, V of S 1 by c whole divided this L come here, Rs plus L square plus 1 by c. Okay, taking 1 by c outside, so VA of s, you can take 1 by c, you can take L outside, so it will become L into R by L into S plus, correct now? S square plus 1 by LC, correct? So it will become 1 by this L goes out, VA of S into 1 by LC whole divided by S square plus R by L S plus 1 by LC. Okay? And this is in the form of, my dear, this is in the form of, this is called P0 plus. Generally this equation can be written like P0 of S divided by VA of S. It's nothing but the transfer function, which is in the form of omega m square whole divided by S square plus 2 theta omega n into S plus omega n square, where omega n is equal to 1 by root LC, R by L is equal to 2 theta omega. So this equation can be but similar to in the form of omega square divided by S square plus 2 theta omega plus omega n square. This is called the transfer function of a second order system. This is very important, my dear. This is very important. Okay, it's very important. And characteristic equation is nothing but, my dear, denominator equal to 0. That is called the characteristic equation. So now the characteristic equation for this second order system will be S square plus 2 theta omega n into S plus omega n square is equal to 0. Very important. Very important. Then omega n is equal to natural frequency, theta equal to damping ratio, which is nothing but actual damping by critical damping. Actual damping divided by critical damping. Actual damping by critical damping. Is it clear? Is it clear, my dears? Okay. And S will be equal to sigma plus J into omega D. That means S is a complex number and the sigma is called the attenuation and this is called the propagation or oscillations. It's called the propagation or oscillation. That's all about the second order derivation. Second order derivation. Okay. Second order characteristic equation and derivation. That S square plus 2 theta omega n square plus S square plus 2 theta omega n into S plus omega n square. This equation you should remember all the time. You should remember all the time, areas. Should remember all the time. So next is undamped system, which means theta equal to 0. So depending upon the value of theta, we can classify the system. Theta is nothing but the damping ratio. So depending upon the damping ratio only, we can classify the system to many numbers. First is undamped system. For undamped system, theta will be equal to 0, my dear. So what was the equation for? Let's see, what is the characteristic equation now? What is the characteristic equation now? Let be characteristic equation Q of S, denominator be Q of S equal to 0, which implies S square plus 2 theta omega n into S plus omega n square equal to 0. But theta equal to 0 now, so which implies S square plus omega n square equal to 0, or S square equal to minus omega n square, or S equal to plus or minus j into omega n. Am I correct? Taking minus 1 root means plus or minus j. Correct na? Minus j into omega. Plus or minus j into omega n will be the value of S. Value of S. So if you draw it on the S plane, so sigma plus j omega plane, sigma plus j omega plane, so you will get like, there is no real term, correct na? There is no real term, 0 plus or minus na, 0 plus minus j omega mean, there will be a j omega n here, and there will be a j omega n here. There is no what? What real term here. That means there is no attenuation, only propagation, only propagation. Okay, so the denominator of the characteristic equation, my dear, it is always gives the value of what? Poles. I already discussed that. A characteristic equation can be represented T of S is equal to some S plus Z1, Z2, etc. S plus Z1 into X plus Z2 into X plus X2, etc. And denominator S plus V1 and S plus V2, etc. So making the denominator equal to 0, then what value of S? You give the value of poles. That's all. So now the denominator equal to 0 will give the value of poles only. That is why the cross I marked here as poles. Is it clear? Is it clear? Next, underdamped system. So this is for undamped, my dear. Next, underdamped. Next, underdamped system. Underdamped system. Underdamped means nothing but, my dear, theta less than 1 or 0 less than theta less than 1. The value of theta is less than 1. That is the meaning of the underdamped system. So what will be the characteristic equation then? S square plus 2t theta is omega n into S 0. Or I can say that what is the value of S here? S, what is the value? So minus b, it's minus 2 theta omega n minus b plus or minus root of b square. For theta square omega n square minus 4ac minus 4 omega n square all divided by 2. Correct? So taking it out outside, minus 2 theta omega n plus or minus this omega n you can take outside, right? Omega n into 2, 4 also take it outside, 2 it will be out, right? 2 omega n root of theta square minus 1 all divided by 2 whole q will be cancelled, minus theta omega n plus or minus omega n root of theta square minus 1. But the value of theta is less than 1 now. 0 to 1 is the value of theta. So it can be modified like minus theta omega n plus or minus omega n into take root of, take minus 1 from outside here now, it will become 1 minus theta square. So it will become, my dear, minus theta omega n plus or minus this minus root taken outside, so it will become j is equal to root of minus 1, so j omega n root of 1 minus theta square. So it will be simplified again as minus theta omega n plus or minus j into omega d, where omega d is called damped frequency of oscillation, oscillation, and which is nothing but, my dear, omega n root of 1 minus theta square. So this is the value of S now. It's value of S now. Then on the pole 0 pole, it will become, this is sigma and this is j omega. So it will be minus eta omega n. So there will be a pole here, minus eta omega n, plus or minus j omega d. Plus j omega d here, minus j omega d, plus or minus j omega, which means which contain both attenuation. System have both attenuation and propagation or oscillation. That's all. Is it clear? Is it clear, my dears? That's all about the underdamped. Next, critically damped. Which means, my dear, theta equal to 1. So what is the value of S now? S will be, what was the equation? Minus theta omega n plus or minus omega n root of theta square minus 1 now, correct? So it will be simply, this zeta equal to 1 means S is equal to minus omega n. S is equal to 1, my dear, minus omega n. Correct? Theta equal to 1 now, so 1 minus 1 is 0. And or term, see what was the Campus equation? S square plus 2 theta omega n into S plus omega n square is equal to 0. Substitute theta is equal to 1 here. S square plus 2 omega n S, correct na? S square plus 2 theta omega n S plus omega n square equal to 0. And what is S now? S will be minus b plus or minus root of b square. Same will be obtained now. Same will be obtained, no change. Same will be obtained, correct? Okay, theta equal to 1 now. So I can arrange like this. So it will be like S plus omega n the whole square, correct now? Is equal to 0. So S plus omega n equal to 0 means S is equal to minus omega n and again minus omega n, which means 2 poles, my dear. 2 poles at minus omega n. That is the meaning. From this, it is not exactly given. Simply S is equal to minus omega n given, but we have to consider 2 poles, right? For every equation, there will be 2 values now. 2 values will be there because S is equal to minus b plus or minus. So minus omega n is one value. Again, another value is also minus omega n because S is equal to number of poles, my dear. So unlike normal arithmetic, if you simply got S equal to minus omega n, you don't satisfy because S is equal to number of poles. So S is equal to minus b plus or minus b square root of b square minus 4s means for plus there is one value, plus minus there is one value. That is the meaning. So for plus it is minus omega n, for minus also it is minus 1. That is why I cross checked this. Okay. So 2 poles at minus omega n. So this result will be what? Sigma and j omega, and minus omega n, there is minus omega n, 2 poles. There will be 2 poles. There will be 2 poles. there will be 2 poles. That's it. So clear? So that is the critically damped concept. Next is over-damped. I think for now, over-damped means theta greater than 1 maybe. In one word question, this will be asked. What is the under-damped? What value of under-damped? Theta less than 1, theta greater than. That condition will be they given in the option. You have to simply take it. Okay, you have to simply take it. That's all. You have to simply take it, that's all. So what will be for over-damped case, my dear? Over-damped condition. What is the value of? We have the general value of s equal to minus theta omega n plus or minus omega n root of theta square minus 1. This is satisfied now. Simple, that's all. This is s value and this is will be sigma into j omega. So is there any omega n term? No. Is there any imaginary term? No. There will be 2 poles, one here and one here. This pole will be minus theta omega n plus omega n root of theta square minus 1, and this pole will be minus theta omega n minus omega n root of theta square. That's all. There will be 2 poles, my dear, and both having this much value. This much value. Okay. So here also only attenuation, no propagation. No propagation. Is it clear? Is it clear, ideas? And what will be the time constant for each of the system? What is that, my dear? What was the time constant for each of the system? What is the time constant for each of the system? So time constant is nothing but, my dear, minus, suppose I already told you now, suppose this is the pole having minus 2 as the value, then its time constant will be tau will be equal to minus 1 by this minus 2 value. Simply 1 by 2. Minus 1 by minus 2. It's simply 1 by 2. That is the time constant concept. So that is the time constant concept. So if there are 2 poles, my dear, if there are 2 poles, one is minus 2 and one is another minus 3. One is minus 2 and another is minus 3. Then the time constant tau will be equal to simply minus 1 by 2. That means consider only the pole which is near to the imaginary axis, that's all. Not the away pole. The nearmost imaginary pole will be considered or constitute the time constant. So for under, and also I explained time constant tau is equal to 1 by theta omega n. Am I right? Previously I derived the expression 1 by theta omega n. So for undamped, tau will be equal to what? Undamped means theta is equal to 0 na? So it will be infinity. For critically damped, tau is equal to 1 by omega n. And for, that's all. Only this you have to note it down. For underdamped and overdamped, you definitely you have to calculate like this. So this you have to note it. This you have to note. Okay. And you have to note one thing, my dear. Over critical. So un, over, under, critical, un, over, under, critical. You have to remember this. The time constant relationships over the whole underdamped, undamped, overdamped, all systems. See, the undamped system have infinity time constant. So it is always higher. So undamped, overdamped, and underdamped and critically damped. You can imagine and think, right? You don't need to forget the order, right? For undamped system, what do you mean by the undamped system? It will not damp. It exists for infinite time. Or after infinite time, if you observe the system is still damping. The time constant will be infinity then. Correct, na? Or overdamped means some damping will be there always. So it having more time constant. Na? Next is underdamped. For underdamped also there will be a damping. Correct? For critically damped there will not be any damping. Theta is equal to 1. Correct? So the order will be always what? The order will be always what? Undamped system. It's undamped system means it's not damping actually. Okay, I'm sorry. It's not damping. It having more time constant. That system having more time constant, my dear. And overdamped means then also it will take many time to attain certain settle down. And underdamped also means there is always some damping now. Overdamping there is always some damping. Underdamping also there is some damping. And critical damping means it is a least time constant system. Least time constant system. Sorry, I pronounced it undamped means it's always damping. No, undamped means it is not damping, but it will take more time to reach the final value. That's the meaning. That you directly obtain from here. T is equal to infinity. Okay. So this just remember this. And overdamped again, underdamped, critical damped. That is the order. Undamped, overdamped, underdamped, critical damped. That is the order. Okay. So that's all for today's session, my dear. So let's meet again tomorrow with 2 sessions. So until then, bye. Take care. Okay.